Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors Chapter 5 Quiz Review Solutions on rational exponents and radical functions. On this problem, they want us to simplify the expression. So one thing that we can do, since we have the same exponent here in this quotient, is we can actually move 15 and 3 together and divide those with a power of 1 over 5. So this is actually going to end up being 5 to the 1/5 power. And then if I'm raising one exponent to another, I just have to multiply the exponents. So this is going to be 5 to the 4/5. And that's as far as we can go. For this problem, we're trying to simplify the cube root of 875. So we need to figure out, first off, if 875 is a perfect cube on its own. So we can go to Desmos for that. CBRT, cube root 875, gives me a decimal, so by itself not a perfect cube. Now the next question is, does it have any perfect cube factors that it is divisible by? So perfect cubes, that would be like, 8, let's see here, 3 cubed would be 27, things like that. So let me do 875 divided by, and let me put it in perfect cube. So 8 doesn't give us a whole number, 27, that's also not working. 64 won't work, but we'll put it in there anyway. How about 125? Oh, 125 times 7 is 875. All right, so I'm going to split this up into the cube root of 125 times the cube root of 7. And then I just have to take the cube root of 125, which is 5. So 5 cube root of 7 then is fully simplified. For this problem, they want us to graph the square root of x plus 5 plus 3. This is a transformation of the square root function, so let me begin by writing what the transformation is. This plus 5 inside is shifting us to the left 5, plus 3 outside is shifting us up 3. Let's write our parent table. That's going to be 0, 0, 1, 1, and 4, 2. And then the transformed table, the g of x table here, since we're going left 5, we can write x minus 5 for that piece. Since we're going up 3, we can write y plus 3. So let me subtract 5 from all the x values in my parent table. 0 becomes negative 5. 1 minus 5 is negative 4. 4 minus 5 is negative 1. And now I move on to adding 3 to all the y values. So 0 becomes 3. 1 plus 3 is 4. And 2 plus 3 is 5. Let me go ahead and graph all these out now. We've got negative 5, comma 3. There we go. And negative 4, comma 4 is right there. And then negative 1, comma 5 right there. Now the original endpoint of the square root function was 0, 0. That became negative 5, 3. So we're starting at negative 5, 3 and just going straight through all the other points like so. For this problem, we're trying to solve this cube root equation. So first we need to isolate the root expression here. Adding 7 to the other side will accomplish that. So we've got 3 over there. And then we're going to raise both sides to the index of the root. In this case, that's third power, but it might be second or fourth. Whatever the root is, that's what we raise both sides to. So in this case, we're doing third power. That gets rid of the root on the left, giving us 5x plus 2. And 3 cubed on the right side is going to be 27. Next, let's solve for x. So subtract 2, that's 25. And then divide by 5, we get x equals 5. Now, because these radical equations can have extraneous roots, it's a good idea to check our solution here. So if we plug 5 into the original equation, let's see what happens. We've got 5 times 5 is 25, plus 2 is 27. So this is the cube root of 27. And the cube root of 27 is 3. 3 minus 7 is negative 4. And negative 4 equals the other side, which was negative 4. So this proves that x equals 5 is the correct answer. For this problem, they want us to do f minus g of x, which basically means we need to take the f function and subtract the g function. So we've got the whole f function right here in red, and this other one I'm subtracting is the g function. This first parentheses I can get rid of for free. But this next one I'm going to have to distribute a negative 1 since we have subtraction. If we had addition, I could also get rid of the second one without making any changes. But distributing that negative 1 now, we have positive x cubed, positive 8x squared. plus 4x, and minus 7. And at this point, let's simplify and combine like terms. So 5x cubed and x cubed gives me 6x cubed. There's only one of the x squared terms. It's this 8x squared piece here. X plus 4x gives me 5x. And then negative 8 plus negative 7 is going to be negative 15. For this problem, I'm trying to find f of g of x, so composition of functions. So initially I need to do f of this g function, f of x minus 3. That just means I'm taking x minus 3 and replacing the x in the original f function with x minus 3. So this is going to be 9 times x minus 3 to the first power. And just to simplify that by making the exponent positive, we can rewrite this as 9 over x minus 3. And we also should make sure that we have the right domain for this one. Now, originally, x minus 3 by itself didn't have any domain issues, but with our modified function here, since if I plug a 3 into the denominator, that would make me undefined because I'd have 0 down here. My domain is going to be x does not equal 3. So this x minus 3 can't equal 0, so x does not equal 3. For this problem, we're trying to figure out the inverse of 6 radical x minus 1. So to start the process, we're going to switch x and y. So we'll write x equals 6 radical y minus 1. And then I'll go ahead and solve for y. So my next step to getting y by itself, I have to divide by 6, so x over 6. And then to undo this square root, I have to square both sides. So that gives me x plus 6 squared equals y minus 1. And at this point, I can add the 1 over to the other side. I'm also going to square the x and the 6, so that'll actually be x squared over 36 plus 1. And I'll rewrite the y as f inverse of x equals, and then x squared over 36 plus 1. Now, one thing I do have to be a little bit careful about here, since my original function had a range that was non-negative because this square root can't give me back negative values, and since it's an inverse, that means the range of the original is becoming the domain of the inverse. So since my original range was non-negative, my inverse domain has to be non-negative as well. So I'm going to have to write x greater than or equal to 0 just to add on to this thing.